Hello friends, I am Nilima. Welcome to our channel about technology. Today in this video we will discuss about difference between TCP and UDP protocol. I have already made separate videos on TCP and UDP protocol. You can watch those videos by the link given in the description. So let's get started. Before understanding TCP and UDP protocols, we must understand what is a transport layer and why it is required. When data is sent from one host to another in the network, it is actually routed. The data traveling in the network adopts various forms for its proper routing and reliable transport. Among the 5 TCP/IP layers, the transport layer has the critical role of providing end-to-end communication services directly to the application processes running on the different hosts. This end-to-end communication is established with the help of protocols such as TCP and UDP. Transport layer also segment and reassemble data from upper layer application and unite it onto the same data streams. TCP, Transmission Control Protocol. It is a transport layer protocol. It is a reliable protocol because it offers flow and error control mechanisms, and it also uses an acknowledgement mechanism to check the safe and sound arrival of data. That is, the receiver always sends either a positive or negative acknowledgement about the data packet to the sender, so that the sender can get the idea about whether the data packet is reached the destination or it need to resend it. The order of data is maintained because it numbers and sequences each segment so that the destination TCP protocol can put the segments back into the order the application is intended. It is a connection-oriented service because the data exchange can only happen after the connection establishment. TCP offers full duplex service where data can flow in both directions at the same time. Now let's understand how the connection is established and terminated in the TCP protocol. The connection is established with the help of three-way handshaking protocol, where the client initiates the connection and sends the segment with sequence number. Then server acknowledges it back with its own sequence number. Clients, after receiving acknowledgement of its segment, sends an acknowledgement of server's response. For connection termination, client and server can send TCP segment with FIN flag set to 1. When the receiving end responds it back by acknowledgement FIN, that direction of TCP communication is closed and connection is released. We have already talked about TCP. Now let's understand what is UDP. The User Datagram Protocol is the simplest transport layer communication protocol. It involves minimum amount of communication mechanism. It is a connectionless service where each datagram is independent with other datagram. The ordered delivery of data is not guaranteed because it doesn't use numbering and sequencing of packets. It is well suited for data flowing in only one direction. It is stateless as it doesn't send any acknowledgement messages. Unlike TCP, it cannot send a stream of data. In UDP, the receiver does not generate an acknowledgement of packet. This shortcoming makes this protocol unreliable as well as easier on processing. We can deploy UDP where the acknowledgement packets share significant amount of bandwidth along with the actual data, such as video streaming, where acknowledging thousands of packets at a time is troublesome and wastes a lot of bandwidth. The diagram shown here illustrates the queuing concept of UDP protocol. In UDP protocol, the port numbers are used to distinguish the processes running on server and client side. Client generates the processes that need services, while server generates processes that provide services. Queues are open for server and client processes. 2 queues for each process. Incoming queues are used to receive messages, while outgoing queues are used to send messages. The queues functions as long as the process is running, and when it is terminated, queues are also destroyed. UDP handles the sending and receiving of UDP packets with the help of the modules shown here. Input module receives a user datagram from IP. It searches the control block table to find an entry having the same port as the user datagram. If it is found, the module uses the information in the entry to enqueue the data. Control block table keeps a track of open ports, and control block module manages the control block table. Here the several number of input queues are used in UDP package for each particular process. And then at the end, the output module creates and sends the user datagram. Now we will compare TCP and UDP protocols with the help of the comparison chart. TCP stands for Transmission Control Protocol, while UDP stands for User Datagram Protocol. TCP establishes connection between the computers before transmitting the data. On the other hand, UDP sends the data directly to the destination computer without checking whether the system is ready to receive or not. TCP is a connection-oriented service, while UDP is a connectionless service. UDP is faster than TCP. TCP is highly reliable, as against UDP is unreliable. The header size of TCP is 20 bytes. In contrast, UDP header size consumes 8 bytes. TCP takes acknowledgement of data and has the ability to retransmit if the user requests. On the other hand, UDP neither takes acknowledgement nor it retransmits the lost data. So guys, this is all for today. If you want to study this topic in detail, you can visit our official website, that is techdifferences.com. The link of topic is also provided in the description below. Thanks for watching. I hope you enjoyed watching this video. Please like, share and review the video, and don't forget to subscribe our channel to never miss a video from our channel.